Every expectant mother knows that what she eats impacts her baby. And now research shows that is also true for our cows. Maternal consumption of ReaShure during late gestation had a positive effect on the in utero calf, setting her up for better health and potentially even higher milk production once she joins the milking string. Learn more at balchemanh.com/launch and launch your herd for life.
So first of all, before I get started, I really want to acknowledge two people that put this talk together. The first one is the late Dr. Charlie Staples from the University of Florida. He actually put this talk together. And Brad Oldick, I see you in the back of the room here. Brad was one of his former graduate students at Florida. And Marcos Sonobi. Marcos did a lot of the work, a lot of the research work that went into this presentation, and Marcos is watching virtually in Argentina this afternoon. So I want to thank both of them. So current practices of raising pre-weaned dairy heifers are good. This is data from the last NOM survey from 2014. You can see mortality from that last survey was 5%. However, so why do we focus on calf performance? So if you look at pre-weaned heifer calf morbidity is still high, about 34% in this last NOM survey. So the effects of poor calf performance due to disease during the pre-weaning period can have long-term negative effects on these animals. So our previous speakers did a very nice job of setting this up. Nutritional programming and the intake of choline by gestating rats and impact on their offspring. So this is another example from rats as far as what can happen. So if we take this pregnant rat and we look at feeding this rat different levels of methyl donors, basically. So if you look at the effect of deficiencies of lipotropes, so this would be choline, methionine, and vitamin B12 in this case, in the diets of rat dams, and what effect did that have on the survival of their offspring post-infection? So you can see that these rat dams, they were fed 4 different levels of lipotropes in the diet during gestation and lactation. And the rat offspring were injected with Salmonella typhimurium at 100 days of age. And you can see what effect the diet of the dam had on survival of those rat pups after they were injected with that Salmonella at 100 days of age, the effect on survivability. What about choline deficiency symptoms in baby calves? You can see this is some really recent research from 1951. There really has not been a lot of choline research done in dairy calves for a number of decades. So from this study that was published back in 1951, so the choline deficiency symptoms they observed back then labored are rapid breathing, weakness, inability to rise, and anorexia within 4 days in these newly born dairy calves that were fed a choline-free synthetic milk at that time. So what I'm going to highlight here for most of the rest of the presentation are 2 cow-calf experiments that were done at the University of Florida. Basically supplementing ruminally protected choline, ReaShure, at 60 grams per cow per day during the transition period only. So in both of these studies I'm going to talk about, ReaShure was supplemented 21 days before expected calving through 21 days post-calving. Of course, we're really talking about in utero effects this afternoon, so we're really going to focus on that 21 days before calving when choline was supplemented as ReaShure. So there are a couple of studies that I'm going to reference here. The first one was published in 2018 in the Journal of Dairy Science, Zimmerman et al. That study that was published then, that has both the cow data and the calf data in that particular article. There was a study then published in 2020, a different study that was run in transition cows. Balchem et al. That was just the cow portion of the study that was published in JDS in 2020. There actually were a couple of calf studies that were run as part of that experiment. They've been submitted for publication now, so I actually get questions about this quite often. So these second studies that were done are not actually published in JDS yet, but they're being submitted now. So I'm going to refer to those as Zimmerman 2021 A and B as we get to those studies. So really just a quick summary here on what happened in the cow. So this is from that first study that was published in 2018 from Zimmerman et al. And again, the ReaShure was only supplemented 3 weeks prepartum or 3 weeks postpartum, but we observed a nice milk yield response out through 15 weeks of lactation. In that study, 4.8 pounds, that's energy-corrected milk on that graph. And this was actually the first time where we actually measured performance throughout lactation. So they monitored these cows out through 40 weeks of lactation. And the ReaShure supplemented cows, 4.6 pounds of increased milk yield out through 40 weeks of lactation in that study. This is the Balchem study that was published in 2020, and we're looking at energy-corrected milk in this study, and 4.9 pounds of energy-corrected milk from the ReaShure supplementation in that study. Again, and that one was out through 15 weeks, monitoring milk yield. So going back to the original Zimmerman study that was published in 2018 in Journal of Dairy Science, they did monitor the heifer calves that were born to these cows that were either on the control treatment or the ReaShure treatments. And what they found through 12 months of age, these heifer calves that were born to ReaShure supplemented dams, they gained significantly more body weight out through 12 months of age, almost 1/10 of a pound increase in average daily gain. And actually, when they measured those out through till first calving, those differences actually were even magnified more at calving in that particular study. So these are the actual body weights. These are those heifer calves that were born to the cows in that 2018 study. These are the heifer calves body weights when they came into lactation. These are their first lactation body weights at that point. So you can see the difference. You can see that difference in body weight immediately post-calving in these heifers that were born to dams that were supplemented with ReaShure during late gestation versus these heifers that were born to non-choline supplemented dams. And we'll come back to more of that later. So, lifelong impacts of receiving choline biomolecules in utero. We'll come back to that question. So, moving forward now to the to some later calf studies that were done at the University of Florida. So, this first study, prenatal choline supplementation, improved health and growth of neonatal Holstein calves. So this first experiment's just looking at heifer calves that were born to ReaShure, either control cows or ReaShure supplemented cows. So we wanted to take a deeper look to see, first of all, could we repeat the this benefit in the calves in a second experiment. And we also wanted to tease out, is this an in utero effect that we're seeing, or is it a colostrum effect from these ReaShure supplemented dams? So it's a 2x2 factorial design. So half of these dams were fed a control diet without choline supplementation the last 21 days pre-calving, and half received ReaShure the last 21 days pre-calving. And then there were two colostrum pools that were created. There was a colostrum pool created from these non-supplemented dams that show up in blue down here. And there was the second colostrum pool was created from the ReaShure supplemented dams. So 2x2 factorial. So half of these calves were exposed to choline biomolecules in utero and half weren't. And then within that, half either received control colostrum from the non-supplemented dams or half received colostrum from the ReaShure supplemented dams. So the heifer calf results, and everything I'm going to show you right now, these are all in utero effects because that's the purpose of our pre-conference today. So late gestation exposure to choline biomolecules increased dry matter intake of both milk replacer and calf starter during the first 21 days of age in heifer calves. So again, this is an in utero effect. So that's the increase in milk replacer intake, and that's the increase in calf starter intake. Second benefit was a reduction in the incidence of fever in these heifer calves. So a reduction from 58% in these control calves versus 31% that received the choline biomolecules in utero. These heifer calves that were born from the ReaShure supplemented dams also had increased concentration of red blood cells and white blood cells. And this improvement in average daily gain that was repeatable, we saw that in the second study. So at 300 days of age, there was a 1/10 of a pound improvement in average daily gain in these heifers from the ReaShure supplemented dams. This is a survival curve of calf starter intake. So this is just in the heifer calves that were born again. And so this is what proportion of the heifer calves were not consuming at least 3 pounds of calf starter per day for 3 consecutive days before weaning. So they weaned at 56 days of age. They started to reduce milk replacer consumption at 49 days of age. And you can see there's this one treatment that stands out here where the calves were not consuming starter intake very well as they started weaning these calves. And it's this NN treatment. So those were the calves that were not exposed to the choline biomolecules in utero, and they also received the control colostrum from these dams. So that's the NN. The blue line with the white circles did not receive the choline biomolecules in utero, but they received colostrum from the ReaShure supplemented dams. The CN received the choline biomolecules in utero, but not the colostrum from the ReaShure supplemented dams. And the CC received the choline biomolecules in utero and through the colostrum. There was a second study done with the bull calves that were born to the dams in this experiment. And what they did here, basically same experimental design, and you can see the calf numbers at the bottom of the slide. And these bull calves were exposed to an LPS challenge at 21 days of age. And so what were the responses to the LPS challenge in these bull calves? So rectal temperatures after the LPS challenge. So this graph just shows hours after the LPS challenge across the bottom. So significantly lower rectal temperature in these bull calves that were exposed to the choline biomolecules in utero. Significantly lower respiratory rates in those bull calves that were exposed in utero again. And of course, that's increased respiration rate would be one of the things you would expect to see with an LPS challenge. Significant reduction in acute phase protein. So this is showing haptoglobin, but there were other measurements made as well. And of course, so what did this mean as far as performance of these bull calves? So these bull calves had greater dry matter intake after the LPS challenge, and they gained significantly better after the LPS challenge. So if you measured body weight 2 weeks post LPS challenge, these bull calves that were born from the cows from those dams that were fed ReaShure during late gestation had higher body weights at that point. So this is a really interesting graph. This is a survival curve of both the bulls and the heifers that were born during this study. So there were 111 calves total. So we looked at survival rate out through 24 days postpartum. And so the CC treatment, so again, those calves that received the choline biomolecules in utero and the colostrum from those dams. 25 calves born, there was 0 death loss in those calves. If we look at the NC treatment, so those calves would have received colostrum from ReaShure supplemented dams, but not in utero. 3 out of 25 died. If we look at the CN treatment, so that would have been receiving choline in utero, but not the colostrum. 5 out of 28, and again, this NN treatment really stands out here. So again, these calves that were not exposed in utero and did not receive colostrum from the ReaShure supplemented dams very high death loss, a 30% death loss in those animals. There was not an intentional health challenge there. There was a health challenge, obviously, in the dairy. It did not just happen during this study. They never did pinpoint the exact cause of that, but there obviously was a health challenge here in the herd. So we have been able to replicate that improved average daily gain of Holstein calves that are born to these dams that have been fed ReaShure. Again, this is all happening during the last 21 days prepartum from supplementation. So that 2018 study, so these are the heifer calves out through 50 weeks of age. There's about 1/10 of a pound improvement in average daily gain in these heifer calves that were exposed in utero. That 2021 study, again, the heifer calves, 1/10 of a pound improvement in average daily gain there. And then if we look at those bull calves that were born in that last study, so from birth through 5 weeks of age, those bull calves gained about 1/4 of a pound a day more if they were exposed to the choline biomolecules in utero. So let's come back to this question. Are there lifelong impacts of receiving choline biomolecules in utero? So again, these are the heifer calves that were born in the initial study that was done at Florida. This study that was published back in 2018, Zinobi et al. Again, body weights were significantly higher in these heifers at first calving if they were exposed to the choline biomolecules in utero. This is unpublished data I'm showing you right now. This is pretty interesting. So this is the milk yield of those heifers when they in their first lactation, and there was a significant or there was an improvement in milk yield in first lactation in these animals, about 2.2 kilos. I mean, I know that sounds very similar to your heat stress impacts there, the 2.2 kilo number. So we need to take a further look at this. Obviously, the animal numbers aren't huge here in this study, but it's pretty telling, and it's actually very similar to the impact we see from feeding ReaShure during the transition period. So these heifers were all treated the same once they were born. So what are the potential modes of action of choline in this case? There could be a couple of things at play here. Obviously, one could be we're meeting a choline requirement in utero for organ development and maturation. So as Dr. Klatt said earlier during his talk, on the human side, the requirements are really listed as adequate intakes for humans. So we know that, so this would be for an adult female, so adequate intake of choline, 425 milligrams per day. During pregnancy, that goes up, and during lactation, it's even higher. We don't really know the requirement for this developing calf in utero. So maybe that's part of what's happening here. We do know that phosphatidylcholine is a key to maturation of the lungs in utero. And obviously supplying choline, a bioavailable source of choline to that dam in late gestation could lead to higher phosphatidylcholine that would be available to that developing fetus. If we look at the composition of surfactant from lungs and intestine, there's a very high proportion of phosphatidylcholine in both the lungs and the intestine. So perhaps that's part of what explains these benefits. Of course, the second thing could be what we've been talking about all afternoon, improved expression of key genes that are responsible for growth, health, and immunity due to greater methylation of the DNA in utero.
At Balchem Animal Nutrition and Health, we strive every day to deliver results you can see in your animal's productivity and your bottom line. From a smooth transition into the milking string for your fresh cows, to a happy welcome home from your furry friend. From a strong start in your poultry flock, to consistent weight gains for your finishing hogs. We expect to earn your business and your trust with our people, our products, and our science. Our people have an intense passion for your animals and your success. You can count on us for honest, candid advice and practical solutions for your toughest challenges. As the global leader in choline production, chelation, and encapsulation technology, we take our obligation to you and to the environment seriously. Our products are backed by the most extensive and thorough research portfolio, while our business is committed to advancing environmental sustainability and animal welfare. In the end, it all comes down to results. Balchem delivers real results you can count on, results that exceed your expectations, and results that bring true value to your bottom line. Leading the charge to meet the nutritional needs of ruminants, monogastrics, and companion animals, Balchem offers a growing portfolio of nutritional products and a dedication to innovation and industry sustainability. Balchem is here to solve today and shape tomorrow.